All right, thank you all so much for being here tonight. We're going to go ahead and get started. So we're going to have a few questions for you at the beginning. So how many of you have been here for all 4 evenings of Explore Engineering? Anybody? Yeah? Oh, awesome. Good to see you all in the back. How many of you, is this your 3rd evening of the Explore Engineering Week? Okay, awesome. Okay. How about your 2nd? What does that tell you? Yeah. How many of us your 1st? Oh, you do not want to admit that out loud there, friends. So for those of you who don't know me, my name is Marlena Lester. I'm the Director of Advising here in the College of Engineering. So we do have a few housekeeping things to get us started for the evening. But tonight we are going to hear from representatives from electrical engineering, computer engineering, and computer science. Also, at the conclusion of the evening, there will be tables set up for students to address questions for you from the ambassadors. We will also have a question and answer session. So feel free to come on in, have a seat, no worries. Okay, so a few things that I want to kind of remind us about tonight. Please make sure that you silence your cell phone. And in traditional fashion, I'm the worst at it, so I'm going to do it with you. Okay. Also, please refrain from using your laptop. So if you do have your laptop, please go ahead and shut that down for the evening. And also, please refrain from talking to your colleagues, your friends during the evening to kind of make sure everyone can hear and learn from the departments that are here to teach you about their program in the College of Engineering. If you are here for the Engineering 1215 or 1414 class assignment, there will be a QR code and a URL for you to fill out an assignment survey. We will then share that assignment survey with your instructors at the conclusion of tonight. Probably sometime after we get all the data collected, we'll share it with engineering education faculty and instructors, and you will be able to get credit for being here tonight. If you are curious about recordings from this week, maybe you weren't able to come to one of the sessions, but you do want to go back and reference it, hopefully in about a week or so, I will email you all the recordings so you will have those to be able to go back and reference. I will get our folks from production services to provide that to me, and then we'll share that out. One of the things that I also want to highlight is that in all the emails that I've sent out this week is some additional resources to help you with the major exploration process. So, of course, this is a very first introduction to a lot of your programs besides College Day, which was at the beginning of the semester. But this is a great way for you to hear directly from the departments. We also have a really robust Explore Engineering website where you can learn about the different disciplines. You can get some information in a clearinghouse kind of fashion and some really factual details to do some comparisons between different departments in the college. There's also a few other little resources. So if you're completely confused on what you want to do, that's perfectly okay. There's a great resource to show you how to explore majors, from everything about learning about yourself, career assessments, self-assessments, all those kinds of things that you can do with partnership with our Career and Professional Development Office. And also never be afraid to reach out to your academic advisor in engineering education. They're equipped to handle all of these kinds of questions about major exploration and the different disciplines in the college. There's also a little snapshot about engineering majors at a glance and also engineering career resources. So this is all housed within the Explore Engineering website, so you can find all of these resources and in all of the emails that I've shared this week. One of the resources that was also showcased is a Minecraft Museum for Engineering. This is a new initiative. It started with engineering education and some students and faculty to showcase all of the different engineering disciplines. So if you are into Minecraft, how many of you do Minecraft? Woohoo! Awesome. So this particular version of Minecraft is a free version. I mean, even if you have, I don't really know, honestly, the details, but this is I'm told it's free. You can download it. And what's really great about this is you can go and explore through a mon about all of the different engineering disciplines, which is really cool. So definitely make sure that you take advantage of that. You have some downtime on a weekend or something, take advantage of utilizing this particular resource. So we still have a few folks coming in. Feel free to come on in. Don't be nervous. It's okay. I can see you, but no one else cares. All right, so what we are going to do is we are going to start the information sessions, and then, like I said, at the end of the evening, we'll have a Q&A panel. And so with the question and answer panel, I do want to highly encourage you to be sitting there thinking strategically about what kinds of questions you might want to ask of these departments and learn more about the departments and ask meaningful questions that maybe you don't have an opportunity to ask anywhere else. Also, keep in mind that the student ambassadors will be here to address any questions that you have as well. One thing I would like to also keep in mind, how many of you, maybe you're just here tonight, and it's okay, we'll call this a safe environment for that question. How many of you are here tonight just because this is the last of the evenings and you don't really know a lot about computer and electrical engineering and you are just here to fulfill the engineering requirement for your class? Okay. So what I would like for those of you in that situation is to keep a very open mind about the departments, all the ones that you're going to hear from tonight, and just all of you in the room, take away at least one piece of information about that department that kind of piques your curiosity. What is something you learned that you didn't know? I'm really, into strengths, Clifton's strengths, and one of my strengths is learner, so I'm always about, what is the one takeaway that you can have from this experience? So please be courteous of those around you. Don't use your phone, turn your laptop off, and we'll get started. So I'd like to invite my colleague from Electrical and Computer Engineering, Dr. Dunning. You are feel free to come on the stage, and we will get started. There is a clicker.
Right here, got it.
Here, and then you can use the arrows too.
Oh, sweet. Thank you very much, Marlena. Okay, can everybody hear me okay? We're good? Yeah. All right, thanks. So I'm Dr. Scott Dunning. I'm director of the Undergraduate Electrical and Computer Engineering program here at VT. So I'm glad you've taken the time, though it may be mandatory, for you to hear a little bit about our degree programs today. So one of the things you may not know is engineering, as it started historically, came with agriculture and the mechanic arts. So when this school was first founded, those were some of the training things that were a focus. Over time, engineering fields developed and went into further and further specialization, right? Anybody know what the first engineering field was? Maybe you heard it before at a presentation. Be civilian engineering, civil engineering, right? Building structures, roads, bridges, etc. And as time went on, as technology increased, we started developing further specializations. So when we went through in the early 1900s with what was called rural electrification, we brought electricity to the people. That started the field of electrical engineering. So our department has both electrical and computer engineering. I'm not going to separate it out into two because we don't separate it out initially. So programs very big. Here on this campus, our EE program's nationally ranked. It was recently just announced that it's currently listed as 15th in the country in terms of rankings, and our computer engineering program is ranked 25th. And this is by the U.S. News and World Report, which is one of the standards people compare degrees on. We're also a rather big program, right? Actually, I think I was typed. I think we're the 4th largest ECE program in the country, not the 5th. We have about 1,100 students. So you think, oh, that's too big. I don't want to be in a program that's big. That doesn't mean you're in classrooms this size, okay? It just means throughout our curriculum, we do have 1,100 students. And also, in our graduate program, we currently have 562 graduate students. What does that mean as an opportunity for you? Well, I came here after spending many years at a smaller university, and one of the things that I really liked about it was that if I had an area that I wanted to focus on, there's 126 faculty in this department. I can find somebody that's doing research in that area, that's an expert in that area. So that's a real benefit of being in a large department, okay? So, and we have some brilliant faculty in our department, and I don't necessarily count myself as one of them. But if you look at we have 4 members already that are in the National Academy of Engineering. A lot of universities don't have any. 30 IEEE fellows. IEEE is the world's largest technical organization. It's the Institute of Electrical and Electronics Engineers. And so to become a fellow, that's the top ranking of that global organization. And we have 30 faculty that are there. Plus, we have faculty that are fellows in other societies. So we have a very well-respected and well-known faculty. We do offer 2 undergraduate degrees that we're pretty proud of and I think would be of interest to many of you. So we have the Bachelor of Science degree in Computer Engineering and the Bachelor of Science degree in Electrical Engineering. So what are you going to learn in these programs? Well, in any engineering, we take math and science and we apply it to solve problems, right? And so if you've been to other presentations, you've seen some of the different disciplines and how they apply it. In your first year classes, you're already seeing, yes, I'm gonna learn some higher level mathematics, I'm gonna learn some higher level science, and then in engineering, we're gonna take that background and start applying those skill sets to solve problems. So when you come into our department, we initially say, you're an ECE. Just like when you applied to engineering, you're in engineering, okay? So you come into ECE and we have all our students take 7 core courses during their sophomore years. And it sets your foundation because there's a linkage between electrical and computer engineering, and they're very firmly linked, okay? So there's certain concepts you need to understand about electricity and electrical control. There's also concepts you need to understand how computers work and how computer control operates. So we have everybody in those same 7 classes, and you're learning the specializations that will come in electrical engineering and computer engineering during your sophomore year, such that as you get to the end of your sophomore year, you're ready to branch into your degree paths and into your specialized majors. So in computer engineering, you can see on the slide that the general concept behind computer engineering is we're looking at designing computer systems, developing new computer systems, testing and integrating hardware and software. So, for example, my colleague tonight from computer science will be talking about some of their focus in developing unique software systems. Well, in computer engineering, we live at that interface between the computer hardware, so the devices we use, whether it's a laptop, whether it's the device in your hand or in your pocket, the cell phone. These devices that we use have computer hardware, but we also write software that interfaces with them. So computer engineers need to be familiar with both the hardware constraints and also how they can interface with the software. So you can see some of the majors that we offer. So remember, you're a computer engineering degree, but then you have a major and you can specialize in one of these areas. For example, chip scale integration. You hear that and you go, well, what does that mean? Well, you may have heard about the CHIPS Act. Everybody hear about the CHIPS Act that just went through Congress? So we realized that during the pandemic, we realized there was a shortage worldwide of computer chips. For example, I had a relative that ordered a new Ford F-150. And they said, yeah, we could give it to you tomorrow, but it won't run because the computer chip that controls the computerized fuel injection and makes it run can't get the chip. So these kind of shortages, we suddenly realized our dependence on how many things have computer control. And they're powered by these chips. The chips have integrated circuits that have, these are electrical devices that may have switches, not one switch, not 10, hundreds, thousands, millions, trillions of chips on one chip. So these switches are all on a chip. So when you look at your computer and you spec'd it out for the computer you wanted, you said, what kind of processor it's got on it? There's trillions of switches in that processor, okay? So in chip scale integration, we are looking at this, what we call nano-level technology. We're getting down into how do we design these chips. In our major controls, robotics, and autonomy, we start looking at how do we control things such as autonomous cars. All right, how are you going to put in a control system to run that car to make the decisions that you and I make every day? Well, you integrate sensors that are bringing information in, you're making a decision, and you have to have programming software which will then process that information and then send outputs out to speed up the car, slow it down, turn the wheel, brake, etc. Okay? In machine learning, this is a very hot field right now. When we think about how do we make a computerized system that can learn and evolve, Okay? So when I think the simplest representation of that is, hey Siri, right? How can it recognize my voice? It has to learn from my voice, right? And so it's going to continually learn voice inflections, whether I'm stressed or not on the delivery. It needs to learn and be able to interpret that information. That's actually a fairly simple system, voice recognition. But machine learning goes far beyond that. When we start looking in patterns and big data and how we can make predictions and have the computer continue to evolve to become more efficient and do the job better. Networking and cybersecurity.
Here's what I found.
Sorry, Siri, on my watch trying to answer the question for you. So in networking and cybersecurity, we know that we live in a networked world, right? And so we have the ability right now, somebody could be sitting at a computer somewhere and know where you're sitting right now. Why? Because you probably have your cell phone with you and some sort of device. We're networked. It is what it is. I took my kids on vacation, and the worst part of the vacation was we were at a beautiful spot in the Maine woods. There's no internet here, Dad, right? We're used to having the internet. When you don't have it, it's challenging. So network systems, the backbone that controls those systems, network engineers are trained as part of this program. Cybersecurity, how do we make those systems secure? That's a big challenge right now, right? So when we think about national defense, we have our National Security Institute that actually evolved from a program within our department, and they're looking at how do we secure our systems nationally. What happens when some rogue individual decides, hey, we want to turn off the power to the United States? Well, we need to prevent that. And so we need cybersecurity engineers that are constantly looking for any ways that somebody may break into our system and make it do something that we didn't intend for it to do. In electrical engineering, you can see the different majors that we have here. One you're going to see right away is, hey, didn't he already say controls, robotics, and autonomy? Yeah, but we have two flavors of that. So in what we call CRA, in computer engineering, is going to be focused more on the computer hardware of those systems, where in the electrical engineering, now we're looking at the electronic circuit that implements the sensors, okay? Communications and networking, we have computer networking, but we also have communication systems. So when I start sending information, you may have it in your room back at your residential center, or if you're living off campus in your apartment, wireless speakers. How do you connect them? Bluetooth communication systems. How do I send information long distance? Maybe I'm using radio frequency information. Maybe I'm using visual cues, so I'm sending beams of light, fiber optics. These would be communications systems that are networked together. So that would be more the electrical side of it. We look at energy and power electronic systems. This was an area that's near and dear to my heart because that's where my focus was. So how do I deliver power to the masses, okay? So when you're at home, you expect when you throw that switch on to always have power, right? Right now, people in Florida are struggling because last one I heard 90,000 people currently without power due to the hurricane, right? Well, we have utilities where the electrical engineers are there. They're going to try to restore power to it. They're going to try to deliver the power where it's needed in an efficient fashion, and they have to maintain and regulate that system. Well, what happens to the grid in the next 10 years as we shift transportation systems to electric cars? It's going to be a big stress on a grid. And who's going to be developing the new technologies that are going to reduce losses while also implementing renewable energy technologies, solar, wind, et cetera, battery storage, all of that technology that needs to come in and work efficiently? That would be people in this major. Also added to that is power electronics. So in power electronics, we start looking at electronic control of large amounts of power. For example, if I want to control a motor, it could be a big motor in an industrial facility. I want to speed it up and slow it down. I do that with electronic control. Jet engine control. So when I hop on that plane, the fly-by-wire system, I have power electronics that are moving power throughout that aircraft. That's power electronics, okay? And we have one of the most world-respected power electronic research laboratories right in Whittemore Hall, funded by the National Science Foundation, been doing it for 30-plus years, which if you ever want to wander over to Whittemore Hall and peek in, you'll see all the patents on the walls that this one research group has developed and really driven technology not only in the nation but worldwide. Micro nano systems, if you want to focus on that, that's really these small technology systems. Everything we want it wearable. Think about the latest watch that came out for Apple, right? They went to what was really, I thought, a very good watch, and they said, let's make it super. Now it's double the price tag, but more and more capability. The only way you can do that is by developing circuits at the micro and nano level. Nano, think the diameter of a hair. That's how small we're talking about. So when we manufacture these things, you're in an environment. We have a small environment to show you the model of where we do research on the 6th floor of Whittemore Hall in a clean room. So you're developing circuits that are so small that any particle in the air could make the circuit fail. So we have to do everything under vacuum, and we do it in a clean room that polishes that air. Every time you go in it, you're in a white bunny suit, you move around. And but it's really interesting work, and it's necessary work for developing the next level semiconductors. When we're transmitting information or we're even sending energy, we can do it both at the radio frequency level and the microwave level. And so you may have seen towers that you assumed were just cell phone towers, but they also may have microwave transmitters on them. And it's one way we do transmit large amounts of information point to point is at the microwave level. So we're talking different spectrums and different bands in the electromagnetic spectrum where we're sending information. If we go even up higher, we get into photonics, where we're sending light information. And so when we look at the electromagnetic spectrum, we have research in different bands of it, whether it's radio frequency, microwave, photonics, etc. And depending on where we want that information to go, is it going underwater? Is it going into space? Then we have different constraints that we're operating on, and you can focus on those constraints that are of interest to you. Space systems is pretty cool. We have ground-based satellite communication systems here on campus, and we're communicating to satellites, and we could be doing anything from monitoring weather patterns, looking at our positioning using our GPS satellites, but really that next generation we're looking at is, well, how can we use the global perspective, take advantage of space to make a difference here on Earth? And I think any of you that are in this room that are looking at a career path, we all look at our first career, and some of the things we look at is, well, I want to know I can get a job. I want to know I can make a lot of money. Well, trust me, any of the engineering disciplines, you're going to find that. But the big thing I think we all ask ourselves is, well, how can I make a difference in the world? How can I help people? Well, in all these fields you can. And in this case, in electrical and computer engineering, we're looking at systems that we can use to make life better for people, okay? And when you just consider from turn of the century where people didn't live very long, right? What was the median age turn of the century? What do you think? Anybody guess? What do you got? 35? 35 to 40, right around 1900, okay? How about today? What is it today? 72-ish, right? Men and women, it's a slight difference, but it's right around 72. Okay, well, the big thing that's changed is you go, well, medicine has changed, certainly, and we've had some of that. Medical diagnostic equipment has changed since then, right? Well, what goes into that medical diagnostic equipment? What goes into the MRI? What goes into the CT scan? These are electrical and computer devices that were built to improve the diagnostic capabilities of our doctors, okay? Maybe these are areas that you want to get an electrical engineering degree or computer engineering degree, but you slide over into the application of it into medical devices. That might be of interest to you. So we have a full staff, and actually I'm really proud to say they're here today in the front row of our advisors in our electrical and computer engineering department. And we've got a great staff who's designed to meet you where you're at. So they can provide academic advising and help steer you based on your interest and also answer those questions about the degree that you may have. And they can provide you advising related to your career. They can help make those connections to employers that are reaching down to us to say, we want your graduates, to those research faculty that may have expertise in an area that you're interested in. And that is part of the role they serve. So they can provide you knowledge, their knowledge about the resources here on campus, the resources in the state of Virginia, or greater resources. And that's available to you if you come into our program. And certainly they can provide referrals to steer you in any of the issues. Maybe I come into one major, I want to switch. What do I need to do? What are the steps? We have our advising staff to do that for you. Lots of student opportunities in our department. I mentioned IEEE. We have a student organization called IEEE, which is the student group feeding into the Virginia chapter, feeding into the international chapter. And our organization's very active. They bring in speakers. They work with one of their subgroups called HKN, and they offer things like, we offer nights called Power Hour, where they'll provide tutoring to students in their ECE courses. We have Fun Fridays, where every Friday, the first Friday of the month, we have donuts that are put out there, donuts and coffee for our EC students. You got to come to Whittemore Hall and be part of it, get the free donuts. It's one of the perks. But we try to create a family with our students. So even though we're a big department, you can get involved and get engaged and get to know your peers. Because these are people you're going to find in industry when you graduate. We have 15,000 alumni from ECE out here in the world. And you've probably noticed, if you've ever traveled, wearing a shirt that says VT on it, what do you hear? Go Hokies, right? I can't walk through an airport without hearing at least one Go Hokies. And that's important to you because you want to succeed in your career, you're going to have connections, okay? If you want to get involved in fun projects, you say, I want to motorize a skateboard, or I wanted to develop a device that would grab a soda from a fridge and put it in my lap. Well, we have what's called the AMP Lab, where students can work on fun projects that are not part of a course. Now, AMP's a complicated word. It's Autonomous Mastery Protocol. But I think of it as a fun lab where you can apply electrical and computer engineering skills working on a project you want. We have an integrated design studio. So we have industry-sponsored projects where our students, every student will do a year-long integrated design project. Generally, it's all industry-sponsored. You're solving real-world problems. And we have the design studio where you can work and build your project with your team. And we help and highly encourage our students to get involved in co-ops and internships. So the idea between your second and third year or your third and fourth year, we try to hook you up with industry opportunities where you can get that taste of what it's like, find out if this is a company where I want to work or a field I want to work in. This is just a slide talking about the AMP Lab and that chance to come in and work on projects. Our students really enjoy it if they have that opportunity to get in to do it. These were a couple of the projects that are kind of fun. Whether it's the matrix cube, a synthesizer that was designed by students, reverberation canceling speakers. It depends. You bring us the ideas. We'll help you and advise you, and we have staff that can also assist you in ordering your parts and helping you get done what you need. For undergraduates in our program, you can get involved in undergraduate research. And so an example here is the Future House. And this is a research project to design and build a net positive solar home. So one of our CP alum that just graduated here in 2022, Tilden Fernandez, got involved in this, was lead engineering on this interdisciplinary project. And as part of it, he got to travel, built the house in Blacksburg here, but also in New York, Alexandria, and even in Dubai. And you think about, well, what goes into a smart home? We've probably seen some TV shows that looked into the possible future. This actually incorporated some of the latest technology, facial recognition security, tracking the location of people inside the house, and integrating smart technologies. One of the things we try to do with this research is we look at what's the technology out there and what's the next step, right? That's what we're trying to do with our research, is saying, what could we do to make life better with the next step? For internships, I've got a couple of examples here just to show you what some of our students have done. Paulo Furman went to work for Huron Systems. Now look at this. He designed reinforcement framework to train autonomous fighter jets to cooperate in dogfights. So if you have an interest in defense-related issues, think about that. The next plane, we're going to have planes up there where you might have one pilot flying a plane and 4 autonomous planes with them that would engage. So they have to incorporate some of the knowledge and skills in decision-making of a pilot with minor direction from the one pilot to multiple planes, okay? He said he loved the experience, applying artificial intelligence to a real problem. So this was while he was in school, he got to do this internship experience using his skills and knowledge in ECE. And he took a position with Huron and working full-time for them now. Another student, Nate Doggett, went to work for Garmin. You may have heard of Garmin. He worked on integrating some external camera functionality into the main display for BMW's new cars, all right? And so when you think about tying into GPS, have the mapping, et cetera. I know if I'm totally screwing this up, I see you guys smiling. But I think about in the cars, right? We don't have the map anymore. Everybody's using their phone, whether you're using Google Maps and Waze. Well, you also have the built-in navigation in the cars. And so he got to see and get involved in some of that that's used for the BMW systems. Other opportunities at Garmin, working in marine products, right? So Garmin has devices such as your fish finders that you put on vessels, et cetera, wearable products, et cetera. And so he got to work in this company, got to see some of the technologies, and got involved in using engineering expertise while still in school. Last one, Honda Research and Development. Kristen Harrell, a CPE that graduated here in 2022, got to work on testing and development of the next lineup of the Honda and Acura hybrids. And they used reverse engineering of the hybrid powertrain, analyzed data taking while driving the vehicles at the Transportation Research Center. So again, try to learn from what the system has and how can we improve it. So there's a lot of career opportunities for you in ECE, and some of the post-graduation opportunities we've listed here, and because our students tend to go from a wide range of places. So we gave you a couple of areas. Automotive industry, defense, gaming, entertainment, robotics, cybersecurity, machine learning, photonics. There's a wide range where electrical and computer technology is being applied, and a degree in this field is the ticket to entry into careers there. We have a large graduate program. You can pursue the professional master's or the master's of engineering. You can also pursue a master's of science or your PhD in computer engineering, electrical engineering, or a related field. I mean, when you look at entry into medical school, I asked one of the faculty at Harvard Medical, I said, what degree, if I was advising my son, what degree would you suggest they have if they think they might want to go into medicine? And he said the highest acceptance rate into medicine are people with engineering degrees. I would have thought biology, chemistry, et cetera. But he said the reason is because you're learning problem solving. And you say, oh, okay. And I lived on a street in Maine with 3 doctors. One was an oncologist who got an electrical engineering bachelor's. So I said, how did you get into doing cancer work? And he says, well, have you ever looked at how we do radiation? A lot of it is electrical media that we're controlling to direct radiation. I talked to an anesthesiologist. He got his electrical engineering degree as a bachelor's and became an anesthesiologist. He said, Scott, I work with electronic systems to keep patients alive while they're doing surgery. It was a natural fit for me. And the last one, electrical engineer, that became an ophthalmologist, an eye doctor. Same thing. He said, I liked my electrical engineering degree fundamentals, but I applied it in a medical field in ophthalmology. So I hope that you'll consider this as one of your degree options. I think any of our engineering degrees and computer science are all great opportunities for you. Whether you go computer engineering degree path or electrical engineering degree path, they're great opportunities, and we want to be here to answer your questions today, but also anytime you want to come by, you've now met me, you can find me, and I'd be happy to talk to you about our degree options. So that's all I've got for now. And I don't know, how do we hand it off? So there you go. That's our ways to connect. ecadvise@vt.edu. So now I'm going to hand off to my colleague in computer science, another great degree option for you.
Thank you. Appreciate it. Very good. Is this you?
That's me.
Right on. All right. Welcome. I am David Mcpherson, instructor in computer science and also the director of undergraduate operations. So I'm glad you're here. And I am the last one of these. So you all have to be pretty excited to finally have reached the end. So good job. Computer science. Actually, before this, I was actually in the ECE department as well as an instructor. So I know a bit about both of these departments. So I'll tell you a little bit about who we are, what we do, why you might want to be computer science. We got a whole bunch of students, 1,300 or so, and that's actually a little bit wrong. We're up to 1,492. We're growing. Part of that is the Amazon stuff that you might have heard about up in Nova. We are 16% women, which is a little bit low. We'd like to be higher. National average is 20%, so we're not bad, but we would like to be better. So we're trying to improve our diversity, trying to improve all of those things. We give out lots of degrees. Last spring, it was about 400. Obviously, with about 1,400 students, that number is going to be going up as we continue to go. And our ranking has actually gone up as well. It's 29th in the nation, better than 31. So we're getting better, continuing to improve, continuing to make ourselves better and try to make you all better. So, in addition, I should say, to our 1,400 majors, we have about 600 minors as well. So altogether, we have about 2,000 students, which is a lot of students, to say the least. All right, so what do you do? Right, so we've got, just like computer engineering, electrical engineering, we've got a couple of majors. Computer science being the sort of traditional major that we've got. And that major, a lot of people equate that to computer programming, and that's not necessarily the truth. You will do programming in computer science, but that's not necessarily what your job is. A lot of people, when they graduate in computer science, they might be a Dilbert for a year or two, go sit in the cubicle and write some code. But after a short period of time, most of those people find themselves doing other things. For the same reason engineers do other things. They end up with good skill sets coming out of our majors, and they end up being people that are well to do other things. So computer programming is a good part of what our major does, but it's more a tool to solve the problem, not just the end of what we're doing. So it's almost just one thing that we do. So that's sort of the general computer science. It's sort of broad brush. You can do a lot of things with it. It's not just, again, sitting in a box. Secure computing, a bit like the ECE one, focusing on how can we secure our systems, mostly from the software side, because in computer science we tend to stay more on the software side, not to say that we don't have people that get down in the hardware level, but we tend to stay above that. Securing our network, securing those types of things. And then data-centric, so you want to go be Moneyball. You want to go figure out the statistics of the game, figure out how the things go. Big data. I've always said I'm going to get a PhD in little data, but I can't find one. So big data, lots of data, terabytes of information. How do you process that? How do you get information out of that? That's data-centric. So that's sort of the three majors that you can do. I honestly don't know our stats in terms of how many are in each one, but I know that computer science is probably the major one that most people are in. If you don't want to major, you can get a minor. So computer science, again, just a minor in computer science. I know a lot of people in mathematics, economics, statistics, biology, forestry, they might get a minor in computer science because they're doing a lot of data crunching in their jobs. And let's face it, computers are really good at crunching numbers. So if you have a way to do that, a minor in that is a good idea. Cybersecurity in partnership with ECE, where we offer a minor in that, or with them we offer a minor. And then human-computer interaction. So this is one that you might not know a whole lot about if you don't know a lot about computer science. It's a little bit more about psychology, or can be. So how do people interact with computers? How do they know what button to click? Why did they pick that button? Why did they pick the wrong button? Why couldn't they find what they were looking for? Those types of things. What makes a good design for an interface? And then also some more practical things like, how do I put the button where it's supposed to be? Things like that. 3D interfaces, we do a lot with virtual worlds and things like that. I've done some things in those areas. So those are a lot of fun. And we can do, like I said, if you're not in a STEM major, we do have a lot of people that do a lot of computer science-y things that are outside of a computer science or engineering background with a minor in computer science. So that's an option if you end up deciding to do something different. So, similar to ECE, we have tracks within our major. So if you're in our major, you might be getting a computer science major, but maybe you want to focus on that human-computer interaction and not get the minor. So you're taking classes in computer science, but when you get done, your area of focus is in one of these: human-computer, knowledge, information, and data. So how do we store and retrieve information, right? How do we have terabytes of data and find it quickly in a way that's presentable, in a way that we can understand it, things like that. Media, creative computing. So how do we make those cool videos that you see from the animation studios and things like that? How do we put those things together? Scientific computing. So if you are more scientific bent, so how do you deal with a large sparse matrix, 1,000,000 by 1,000,000 with very little data down the middle, something like that? How do you do that efficiently? And scientific and networking. Systems and networking. So systems being a little more closer to the hardware, but not necessarily operating systems, if you want to think of that, or networking. How do networks communicate? How do computers communicate to each other? So those are some areas that are within computer science that you could focus on if that's your preference. Or you can just go broad, sort of cover the whole thing. So what are you going to learn? This actually is one of our former students, one of my former colleagues. She's a PhD graduate now. She works at University of Washington as an associate professor. She was a PhD student when I taught with her. So she was learning things like experiential curriculum. So in the class I taught with her, we did hands-on things, project-based learning. How do you explore those things? The classes that I teach, I try to make them very hands-on. I try to do examples in class, so that you come away with not just theoretical knowledge, but also knowledge about, that's how I actually apply that skill to what we're trying to do. And we try to get you those skills so that you can find those jobs, so you can get, your internships or your co-ops or your job when you graduate. As a student, there are lots of different ways you can get involved. We have a undergraduate research. So if that's a thing you're interested in, if you think you might want to do research, if you think you might want to go to grad school, or you're not even sure, you could do the undergraduate research. We have lots of opportunities for that. We have a whole showcase. The Blockchain Summit, if you know a little bit about blockchain, that was invented here at Virginia Tech, or at least the technology behind it was. Block 1 lives 5 miles from here. Founded by a guy that graduated from our department. 2 different hackathon groups. Actually, VT Hacks, I think, their first faculty sponsor in ECE, actually, when that started. And then we have, this sounds fantastic, the Works of Wonder Student Showcase. I want to go to that just to see what Works of Wonders are. So there's lots of ways you can get involved in those types of things, whether it's hacking or whether it's just being wonderful. Different student opportunities. We have, similar to the IEEE Society, we have an ACM, Association of Computing Machinery. We also, in addition to that, have the Association for Women in Computing, which is part of the ACM specifically for women, to try to help with that. And so we have those 2 groups, the Linux and Unix users group. So if you're a Mac user, you're using Linux, whether you knew it or not. Or if you're just a Linux user, you can use that. I love Linux. CS squared, I had to look this up because I wasn't sure what the squared part of it was. It was for community service. So using computer science in a community service forum. So helping local people here in town. I think they do things over in the rec center over by the pool in town. So they do things like that. So helping people here in the community get involved with computer science in addition to their own meetings and things that they do to try to plan those things. The Artificial and Machine Learning Club. I feel like every other word out of a student's mouth is I'm studying cybersecurity or machine learning. So we have a club for that if you're interested in trying to find those people. The Gaming Project. Actually, I was also the first student advisor for that club when it started 20 years ago. The Tech Hackers is that VT Hacker, the blockchain, if you're interested in that. And the Teaching Robotics and Engineering, I'm actually now the current faculty sponsor for that club. That's also got ECE students and CS students. And what I think is cool about this particular club is it's not just you coming to learn about how to program a robot, but it's actually you helping other people learn how to program a robot. So if that's your area, if that's a thing you think is cool, you can come to this club. First, you might have to learn it. So you might be in the seats learning, putting robots together, programming, and then you might flip it a year later and you might be the one giving the lectures or giving the lessons to the students. It's all student run. So I think that one's a really cool one. That's new to our department. And I think it's a neat opportunity for students to get together, especially if you are that CS student that likes to live in the software, hardware world and wants to do a little bit with the Arduinos or those types of things. You can get in that, get your hands dirty. They have a lot of cool stuff, a lot of cool parts and stuff they put together. This is actually brand new, starting this spring, so not for you all, but it's our Capstone class for software engineering. It's a study abroad. It's going to go to Egypt with one of our faculty members who's from Egypt. He's here now. He's actually my neighbor. And he'll be bringing 8 students this year. I suspect it'll grow by the time you're a senior. Taking them to Egypt for a week-long embedded study abroad. They're going to be working with students from Cairo, Alexandria, and Al Alamein, and they're going to be doing, I suspect, for the whole term, working with those students, but when they go across to Egypt, they'll be looking at how can international problems be solved using computer science. So not just sort of an American's perspective, but also an international perspective in this particular area. Now, in 4 years, it may be not just Egypt, it might be other places as well. We have lots of faculty that have international ties that I think we could easily expand this into other places. So I think this one's really cool. I think this is a really neat opportunity that is new to us. When you graduate, right, you want to get a job. So where can you do this? We have a CS source. It's part of our department. We send emails regularly with announcements about career opportunities or internship opportunities or people looking for interviews and things like that. So you get that from our partners, some of them listed here, MITRE, Northrop Grumman, L3 Harris, and so on, companies you may or may not have heard of, Bloomberg, that do things that are looking for computer scientists to help them solve their problems. So we have those sort of stakeholder companies. And we have others as well that are outside of that circle. But we also have a CS, I think, dedicated only for CS or CS minors, career fair, where 90% of our students graduate, before graduation, actually have an offer. I worked with a student last spring. He had an offer from Northrop Grumman in San Diego, which I think is a pretty nice place to go. I think the weather's pretty good. He was very excited about that. He knew that 2 months before he graduated. So, 41 companies. It's a great place to get yourself in front of them where it's really just going to be you and them. You can talk to them. These are some places you can get jobs. You probably have recognized a fair bit of these companies, right? I don't think I need to say too much about those companies. We do the sort of traditional, software companies, your IBMs, your Microsofts, your Apple to an extent. But then we do some other ones, EA, I think that'd be a great one to work for. I think it'd be a fun one to work for. I don't know about a great one, but that'd be a fun one. So all kinds of cool things. Finance companies are on there, communication companies are on there. So depending on what you like to do, there's all kinds of opportunities for jobs in computer science. Eastman Kodak, which I guess it's not Kodak anymore, Eastman, which I think is a chemical company, but pretty much everybody needs some sort of software to do stuff. So all kinds of fun stuff on there. Advising, it's the same picture. I told our advisors they didn't need to come, but they offered. We do have a great staff of advisors that are growing. I think we hired 2 more advisors this year. since our department's growing. But every student is assigned an advisor basically based off your name, and they will help you with your class decisions. They'll help you with your path through the department. We suggest you meet with them regularly, at least once a semester, to try to make sure things are going well. They can help you with issues as they may or may not arise throughout the years. They can help you with, as you graduate, getting through that, if you're going to go to grad school, things like that. So they're very talented, and they can help you with all of the needs that you might have as a student moving through. And as I mentioned, we're growing, so that staff is growing. I think we're looking to hire, another 1 or 2. So we are definitely continuing to add more help for students because, as I mentioned, we are fairly large. And here's how you can find us. So we are in Torg. We just moved, so up until a couple years ago, we were actually off campus, but now we are mostly all in Torg. So if you ever walk through Torg, the first floor of Torg, and you wonder who all those people are sitting at the tables with their laptops open, that's us. That's computer science. My office is in there. I'm 1200 Torg around the bridge. I like to tell people I'm the troll under the bridge because I'm right there under the bridge in the corner. You're welcome to stop by. If my door is open, you can knock. I'm there Monday, Wednesday, Friday in the morning. We have Facebook accounts and Twitters and Instagrams and all that good stuff. You can check us out there if you're looking for us. You can email csundergrad@vat.edu if you want to just talk to people or try to get a hold of someone. They can try to help you out and get you in there and see what's going on. Yeah. And I am done.